So a triple integral on rectangular coordinates. So what we're going to do is we're going to find the volume using an iterated triple integral using this formula. The volume is going to be the triple integral over the domain with respect to v. So our example is going to be find the volume bounded by the first octet and the plane 6x plus 3y plus 2z is equal to 6. So what I'm going to do is I'm going to draw this thing, and then we can figure out the limits of integration. So the x, y, z space. Now, in order to find the picture of the first octet, what I'm going to do is I'm going to find the x, y, and z intercepts. So if I want to find the x-intercept, it's just like we do in a pre-calc class. You set the other ones equal to 0. So setting y and z equal to 0, we can see that 6x is equal to 6, so x should be equal to 1. If I want to find the y-intercept, you let x and z equal 0 and solve for y, so y would be 2. And if I want to find the z-intercept, you let x and y be 0, so z would be equal to 3. So what we get is we get the plane bounded in the first octet from these intercepts. So I'm going to find that volume. I'll dot the back line just to make sure you know that this is basically a triangular prism. So in order to do this, we have choices. We can do dx, dy, dz, or dy, dz, dx, and so on. And it's really defined by the shadow that you want. So what I'm going to do is I'm going to do a yz shadow. So yx shadow. So what I'm going to do is this is going to be the shadow of the curve of the integral. And I'm going to integrate this, let's say, in the x direction. So that means it's going to be perpendicular to the x direction. So I'm going to integrate from, well, you can see that x is going to be bounded from 0 to 1. So 0 less than or equal to x less than or equal to 1. And the y's are going to be bounded between, well, this is going to be the minimum y. So 0 would be less than or equal to y, less than or equal to. Now this point right here is that y, but it's defined on this line right here, which really is the intersection of this plane in the x, y plane. So you can see that the xy plane is when z is equal to 0. So if you plug in z is equal to 0, that equation is going to be 6x plus 2z. Sorry, z is equal to 0 plus 3y is going to be equal to 6. And I can solve this thing for y. So 3y is going to be equal to minus 6x plus 6. So y is going to be equal to minus 2x plus 2. So that's what we have. This is going to be minus 2x plus 2. Now, in order to figure out the limits in terms of the z coordinates, so what is z going to be about in a 3D printer? Like a 3D printer is going to print, in that z orientation. So I need to know where's the bottom of the print, where's the top of the print. So you can see that the bottom of the print, I'll do a vertical line to try to show this. So the bottom of that vertical line is going to hit the shadow, which is the xy plane. And the top of that vertical line is going to come out of this, this plane right here as it goes up. So this dot being the minimum, which is z is equal to 0 because it's the xy plane. And this being, well, this green plane right here, which means I'm just going to have to solve that for z. So solving that for z, we'd have 2z is equal to minus 6x minus 3y is equal to 6. So dividing everything by 2, z is going to be minus 3x minus 3 halves y plus 6 divided by 2 is going to be plus 3. So this is going to be equal to minus 3x minus 3 halves y plus 3. Which means our integral can be defined from the integral. So x's are going to be 0 to 1. So this will be dx. Then we have the integral from 0 to minus 2x plus 2. That's going to be our dy. And then we have the integral from 0 to this plane, which is minus 3x minus 3 halves y plus 3. And this is going to be dz. So I'm going to pause it. I'm going to write that up at the top, and then we're going to find we're going to take the antiderivative of this. All right, so we're gonna integrate this. So first we have to integrate with respect to z, and since that function is 1, the integral with respect to z is just going to be equal to z. So integral from 0 to 1, integral from 0 to minus 2x plus 2 of z evaluated from bottom to top. So minus 3x from top to bottom, 3 halves y plus 3 dy dx. So plugging in the top limit and then the bottom limit, we're going to have minus 3x minus 3 halves y plus 3, of course, minus 0, and then dy dx. So now I integrate this with respect to y, which means anything that's on a y is going to be a constant, so that's a constant. So the integral from 0 to 1 of minus 3xy, integrating with respect to y is going to be y squared over 2. So this is going to be minus 3y squared over 4. And then integrating this with respect to y is going to be plus 3y, evaluated from, the lower to the upper, dy with respect to that, and then this is going to be dx. Now remember, these are y's, so when you plug these things in, top minus bottom, these are going to go into your y coordinates of your y variables. So this is going to be minus 3x times minus 2x plus 2 minus, say, 3/4 times y squared, which is minus 2x plus 2 squared, plus 3 times minus 2x plus 2. And then I'd plug 0 into all three of these terms. And this would be 0, this would be 0, this would be 0, so I'm not going to write it. So this is dx. So it would be helpful to simplify this first before we find its antiderivative. So integral from 0 to 1 of 6x squared minus 6x. I'm going to square this first. So 4x squared, so remember this is going to be first times first. Outside is going to be a minus 4x. Inside is going to be another minus 4x, so this will be a minus 8x. And then your last is going to be 2 times 2, which is going to be 4. Don't forget you have to FOIL that. And this is going to be a minus 6x plus 6 dx. Sending this through, so this is going to be equal to the integral from 0 to 1 of 6x squared minus 6x. So this is going to be a minus 3x squared. This is going to be the 4's are going to cancel, the negatives are going to cancel, that would be positive. So this is going to be a 6x. And the 4's will cancel, but it'll be negative, so this is going to be a minus 3. And we still have that minus 6x plus 6 dx. All right, finish simplifying. This is going to be the integral from 0 to 1. 6x squared minus 3x squared is 3x squared. The 6x's, those will cancel, but I still have a negative 6x. And minus 3 plus 6 is going to be plus 3 dx. Now we just integrate this from 1 to 0, so this would be 3x. Let's make sure that looks prettier. So this is going to be a 3x cubed over 3 minus 6x squared over 2 plus 3x evaluated from 0 to 1. So this is going to be x cubed minus 3x squared plus 3x evaluated from 0 to 1. When we plug in 1 cubed minus 3 times 1 squared plus 3 times 1. Minus when you plug in 0, they're all going to be equal to 0. So we can see that this is going to be 1 minus 3 plus 3. So this volume is 1. Now, we have a choice. We don't have to do dz, dy, dx. We can do them in other orders as well. I'm not going to take the antiderivative of the other ones in the other orders, but I'll show you another way we can do it. We just have to choose a different shadow, and then we can do your dx, dy, dz, or any other orientation that we want. So we'll draw it first, determine a shadow, and then you'll figure out what the new will be. So I put the same example up there. But what I want to do is I want to change the limits of integration. And I'm going to choose a, let's do an XZ shadow in this case. So we can see that we're going to shadow across this XZ plane. And the orientation I'll take, let's slide in the x direction. So that means this is going to be perpendicular to the x direction. So we can see that x is going to go from x is equal to 0 to x is equal to 1. So 0 less than or equal to x less than or equal to 1. You can see it slide in the x direction from 0 to the x-intercept. Now your z values are going to be defined by the minimum dot and the maximum dot on here. So the minimum dot being 0 and the maximum dot. Remember that that this is going to be this plane, except notice that y is equal to 0. So if I plug in y is equal to 0, we're going to have 6x plus 2z is equal to 6. So 2z is going to be minus 6x plus 6. So z is going to be equal to minus 3x plus 3. So we can see that this is going to be minus 3x plus 3. Now our bottom and top is going to be oriented in the y direction. So if I determine its minimum coming in the y direction, and the maximum is still going to be coming out of this plane, we have to find the values of those particular dots, and those dots are going to be your y values. Now you can see that it's going to go through the shadow, which is the xz plane, so this is going to be y is equal to 0. And then it's going to come out of this particular plane here, except it's going to come out of its y coordinates. So I just have to solve that plane for y. So 3y would be equal to, subtract those, we have minus 6x minus 2z is equal to, plus 6, did that last time, plus 6. And then divided everything by 3, y is going to be equal to minus 3x minus 2/3 z plus 6. So that's going to be the maximum here. So this is the integral from minus 3x minus 2z over 3 plus 6, which means we can integrate now in this orientation that value is going to be the integral from x is going to go from 0 to 1. Now z is going to go from 0 to minus 3x plus 3. And then y is going to go from 0 to minus 3x minus 2z over 3 plus 6. So that was the y, this is the z, and this is the x. And working through that, you'll see that you get exactly the same value as well. And just in case you have a little glare up here, I just rewrote the integral to show you that it's going to be equal to 1.